Okay, let me do a video real quick on the force math that we did in class. I'll go over the first 4 pages of this, and then the rest of it you guys can pick up on your own. So we'll get started here. Alright, so this is a basic free body diagram that we've drawn with each of the forces labeled. So you'll notice that we got friction, normal, gravity, which remember can be calculated by taking mass times gravity, and then the applied force. The question says that the force is applied to a 6 kilogram mass, and it moves rightward across a rough surface at a constant velocity. My advice is anytime you see these words constant velocity that you make a point to highlight them somehow. Put a box around it, underline it, highlight it, whatever. Because remember, constant velocity means that the object is not changing its velocity. It's at constant cruise control, or an acceleration is 0. That's very important in terms of force. If acceleration is 0, then your net force is going to be 0. And if that's true in terms of the free body diagram, that means that each of these sides, this friction, must be canceled out by this applied force, so therefore we know the applied force is also going to be 15 newtons. Now the gravitational force is going to be mass times gravity. In this case, that's going to be 6 times 9.8. And if you type that in your calculator, then you're going to get, I believe it's 58, let's see, 6 times 9.8, 58.8. So that's going to go here and also here. And we are finished just like that with this first question. Very important, again, constant velocity. Moving on to the next question. Once again, we see here that this object is moving across a rough surface at constant velocity. Very important. Once again, our acceleration is going to be 0 and our net force is going to be 0, which means that each of these forces must be canceled out by the other. This item is 10 kilograms, so 10 times 9.8, mass times gravity, is going to give us our force down as a result of gravity, and likewise our normal force would be the same, because these two will cancel each other out. Now in terms of our applied force and our friction force, it does not give us either of these, but it does give us this coefficient of friction. We now have a formula that says if we want to solve for friction force, and we're given the coefficient and the normal, we can take the mu, multiply it times the force normal, and that will give us our coefficient of friction. So in this case, it'll be 98 times 0.2, and I believe that's going to give us, looks like 19.6. And as a result of the net force being 0, that makes the applied force also 19.6 newtons. And so there you go, just like that. Number 2 is done. Number 3 is our first example of a problem where it gives us an actual acceleration. It's a 5-meter object and its acceleration, and it has a coefficient of friction of 0.1. Okay, so you can do this multiple ways. What I like to do is go ahead and solve for the net force. Net force is mass times gravity. So 5 times 2 is going to give us a net force of 10. I like to do that because what that does is set me up to know how my forces are going to lay out on my free body diagram. This is a 5 kilogram object, so 5 times gravity is going to give us our gravitational force and our normal force. And then we know that this applied force right here minus this friction force is going to have to give us our net force of 10. So we can calculate our friction force because we have the mu. So if we take our 49 newtons of our normal force times our 0.1 for our mu, we get 4.9 newtons for our friction force. And again, we know that the applied force minus the friction force has to equal 10. So that would make our applied force 14.9, because if we take 14.9 minus 4.9, we end up with 10. And then finally, the fourth one, we have another object. This one has a rightward force of 25 newtons, so that's right there. And it is accelerating at 2.5 meters per second, and it has a mass of 4 kilograms. So once again, I'm going to go ahead and solve for the net force by taking the mass times the acceleration. 4 times 2.5 gives us a net force of 10. So when I add all these forces together, I'm going to need to end up with 10. Gravity for this object is going to be 4 times the 9.8. Again, that is mass times gravity. And when I do that math, I'm going to do that real quick on my calculator. 4 times 9.8 is going to give me 39.2. And that's also going to be the normal force. Now in terms of the applied force and the friction force, again, this applied force minus the friction force must equal 10. So that means 25 minus 15 newtons is going to give us our 10. So that is the force that we have there, and all that's left is to calculate the number that goes here in terms of the mu. So if you're given the normal force and the friction force and asked to solve for mu, then the formula becomes the mu, which is the coefficient of friction, is going to be your friction force divided by your normal force. So friction divided by normal, and if you do that math, I believe you're going to get 0.38 as your mu. And that takes care of the first 4 problems. The rest of them you should be able to work on your own. If not, please come and see me and I will give you additional help. Thanks. Have a great day.